And now, on this new drawing is shown the frontal projecting straight line. This line is parallel to the horizontal and profile planes projections. It means it is perpendicular to the frontal plane of the projections. It means that we can see this line like a segment on the horizontal and profile planes, and it is projected in point on the front plane. You can see this on our right drawing. We have a point on front plane, point B1, and we have a line on our horizontal plane. On this drawing is shown the horizontal projecting line. This line is parallel to the frontal and profile planes of projections. It means that it is perpendicular to the horizontal plane of projections. On this drawing, you can see that this line is projected in a segment on the frontal and profile planes, and this line is projected in point on horizontal plane. You can see this point, it is denoted A1, and you can see a vertical line on our frontal plane. On this drawing is shown the profile projecting line in parallel to the horizontal and frontal planes of projections. It means that it is perpendicular to the profile plane of projection. On the drawing, you can see that this line is projected in a segment on the frontal and horizontal planes and projected in point on profile planes. If the segment is parallel to the plane, it is projected on it without distortion. In other cases, we need to find its natural value. To find the natural value of a segment, we can use the method of a right triangle. This method is based on the action of finding the hypotenuse of a rectangular triangle. One side of this triangle is horizontal of the line segment projection, or frontal line segment projection, and other side represents a difference between the ends of this segment projection on the horizontal or frontal projection plane. So, on this drawing, we can solve this task and find the actual value of a segment. This drawing shows us that we have a line, a segment AB. We can see here the construction of a natural value of this segment. To find the full size of segment AB, we need to construct a right triangle AB, A0 on the horizontal plane. One side of this triangle, AB, is the projection of the segment AB on horizontal plane. The second side, perpendicular to this one, A0, is equal to some difference. This difference we can get only on the frontal plane. It's the segment ZA minus ZB. It's the difference between the heights of the points A and B on the frontal plane. So we take this segment and construct perpendicular line to the segment AB on horizontal projection plane. On this perpendicular line, we mark the difference ZA minus ZB. Then we should connect the new point A0 at the end of our segment perpendicular to the segment AB. So we connect the new point A0 with the point B and get the natural value of the segment AB. On our drawing, this natural value is denoted with red color. And now let us talk about position of a point on a line in space. On this drawing, we have a line L and a point A on it. The line with the point is located on horizontal plane. If it is known that point B belongs to this line and the horizontal projection of this point also belongs to the horizontal projection of the line, then the frontal projection of this point will also be located on the frontal projection of the line. This example is shown on our drawing. We get point B1 on the line L1. We project point B on the line and get this line from we project point B from line L on the line L1 and get point B1. This is one of the main properties of a point and a straight line. And I want you to explain one more property of a point and a line. On this drawing is shown an example of the division of a straight line segment in some given ratio. The segment CD is divided in the ratio 2 to 5. To do, we should divide it at this ratio 2 to 5. To do this, we draw a free line from point C on the horizontal plane. Then we divide this new free line into 7 equal parts. The next step, we should connect the end of the 7th part with the point D on horizontal projection plane. Now, to divide our segment in the ratio 2 to 5, we need to connect point 2, the second segment of our new line, with the line CD, and we construct the line parallel to the segment D7. So our line B2 is parallel to the line D7. Now, on horizontal projection plane, we get the division of a straight line segment in given ratio 2 to 5. To get the same construction on frontal plane, we should project point B on the frontal projection of segment CD. As you see, we connect point C and C1 with perpendicular line. And point D also is connected with point D1 with perpendicular line. That's why we need to construct from point B perpendicular line to the intersection point with segment C1D1. We project our point B from the horizontal plane, projection plane, on the frontal projection plane. We get point B1. Our segment C1D1 is divided in some given ratio 2 to 5. That's the example how you can use the property of the points in space, the position of the points in space in life. And at the end of our lecture, I want to show you one more example of the point and the position in space. This drawing illustrates the relative position of a point and a straight line. As you can see from this example, we have 5 points. Point A is located on the line L on horizontal projection plane. We have point A1 on the projection of the line L1, and on the frontal projection plane we have the same point A2. It is also located on the projection of the line L2. So, point E is located on the line L on both planes, horizontal and frontal. It means that point A lies on the line, and both points and the line belong to the same plane. So I can consider that point A belongs to the line in a space. Now, second point, point B. The projection of point B is located under the projection of the line on the frontal plane, and on the horizontal plane the projection of point B belongs to the projection of the line. It is located on the line L1. What does it mean for us? This means that the point B in space is located below the line L. I even can say that this means also for us that the point and line don't belong to the same plane. So, our point B in space is located below the line A. On the third example, the projection of point C is located above the projection of the line on the frontal plane and is located on the line on the horizontal plane. What does it mean for us? This means that the point C is located above the line in space. That means that the point does not belong to the line. The next point, point D. The projection of point D belongs to the projection of the line on the frontal plane and is located above and to the left of the line on the horizontal plane. What does it mean for us? This means that the point D does not belong to the line. The point is located behind the line in space. And the last point, point E. The projection of point E is located on the projection of the line on the frontal plane and doesn't belong to the projection of the line on horizontal plane. On horizontal plane, the point is located below and to the right of the line. For us, this means that the point does not belong to the line and is in front of the line in space. So, you can see from this drawing that only when the both projections on the frontal and horizontal planes belong to the line, this point is located on the line. If only one projection of the point belongs to the line, this point is not located on this line in a space. So today we have discussed with you the main properties of the lines in space. The knowledge about position of the lines and points in space will help us in future solve problems of descriptive geometry. Goodbye, good luck.